This question comes from the CAPE Applied Mathematics Unit 1 syllabus. We have a random sample of 100 observations from a normal population with mean mu, giving the following data. Summation x is equal to 8200. That's all the observations, the 100 observations, when we add their values, is equal to 8200. And summation x squared is equal to 686,800. So when we square all of the values and we sum them, we get 686,800. We are required to calculate a 99% confidence interval for the population mean mu, and then explain what the interval means. Then we have to calculate a 90% confidence interval for mu and comment on it. So we're going to compare the results obtained in part A with the results in part C and comment on the significance. First of all, confidence interval for population mean mu is given by x bar, that's the sample mean, plus or minus z star, which we know that value varies according to the level of confidence. For a higher level of confidence, example a 99% confidence interval, z star would take on a greater value than, say, for a 90% confidence interval. Z star sigma over root n, where sigma is the sample standard deviation and n is the sample size. So x bar, as we know, the sample mean is equal to summation x over n, which in this case is 8200 over 100, and that's equal to 82. So the sample mean is 82. So our confidence interval will be centered around 82. Now we don't know what sigma is, so we use an unbiased estimate of the variance actually. So sigma hat squared will give us the variance, and then we take the square root to get an unbiased estimate of the standard deviation. This is equal to n over n minus 1 by sigma x squared on n minus x bar squared, and we know that x bar is equal to 82. This will be equal to 100 over 99 times summation x squared. We know that 686,800 divided by n is 100 minus 82 squared. Okay, and this will give us 100 over 99 by 68 minus 6724. Good, and that's sigma hat squared. Sigma hat, when we take the square root of this rounds off to 12.06. So we're going to use 12.06 as an unbiased estimate of the population standard deviation. So we have two unbiased estimates, x bar, sample mean, and sigma hat. We're now going to plug these into the formula for confidence interval. and Z star for a 99% confidence interval is equal to 2.576. So our 99% confidence interval, mu, is equal to x bar, which is 82, plus or minus 2.576. That is Z star for a 99% confidence interval, by sigma, which we will be using sigma hat as our unbiased estimate. That's 12.06 over root n. N is 100, so root n will be the square root of 100, which is 10. And this is equal to 82 plus or minus, and that's going to give us 3.11 to 2 decimal places. So the lower limit will be 78.89, that's the lower bound, and our upper bound will be 85.11. So this is our 99% confidence interval for the population mean mu. For part A, it's going to be somewhere between 78.89 and 85.11. To answer part B, explain what the interval means. This means that we are, because it's a 99% confidence interval, we are 99% certain that the true value, the actual value of the population mean mu, lies somewhere between 78.89 and 85.11. We are 99% certain of this. That's what a 99% confidence interval tells us. We can be 99% confident that the interval we calculated captures the true value of the population mean mu. So that is part B. And part C, so we are 99% confident that our interval captures the true value of the population mean mu. That's what the 99% confidence interval tells us. Part C, we have to calculate our 90% confidence interval. We will do it in exactly the same way. So mu is equal to x bar plus or minus. Now our z star this time is going to be 1.645. So z star for a 90% confidence interval is 1.645. Sigma over root n, and that is equal to, again we know that x bar is 82 plus or minus, so the only thing that changes is z star is 1.645. Again we will use our unbiased estimate sigma hat, that is 12.06 over 10, and this is equal to 82 plus or minus 1.98. So the lower limit, the lower bound, is 80.02. That's 82 minus 1.98, and the upper limit will be 82 plus 1.98, which is 83.98. So again, the significance of this interval is that we are 90% certain or 90% confident that the true value of the population mean mu lies somewhere between 80.02 and 83.98. finally we're required to comment on this. So if we look at the results again of our 99% confidence interval, we had a wider interval. So both of them are centered around 82. The sample mean is exactly in the middle of the 99% confidence interval and the 90% confidence interval. But our 99% confidence interval is wider. As you see, the lower bound is 78.89, whereas the lower bound here was 80.02, and the upper bound in our 99% confidence interval was 85.11. Here in the 90% confidence interval, it's only 83.98. So this interval is narrower. The 90% confidence interval is narrower, and the 99% confidence interval is wider. And the reason for that is because for the 99% confidence interval, we are more confident that it captures the true value of the population mean mu. And in order for us to be more confident that it will capture mu, it has to be wider. So that would explain why we obtained this wider interval for the 99% confidence interval as opposed to this narrower interval for the 90% confidence interval. For us to be more certain that we capture mu, we need a wider interval.